Welcome to Elimu TV. This is Teacher Faith taking you chemistry, Form 4. And to my viewers, send us your name and the location where you are watching us from. The SMS number is 21126. We are looking at Form 4 work, and you are in the first topic, acids, bases, and salts. And in the first lesson, we had discussed about acids, the definition, and I said that at Form 4 level, we don't give that definition of Form 1, whereby you are saying an acid is a substance that reacts with a base to give salt and water as the only product. We said that in Form 4, we define an acid as a substance that dissociates in water, that dissolves in water, to give hydrogen ions as the only positive ions. And we were able to see that acids can be classified in two ways. We had the first category was of weak acids, and the other one was about strong acids. And we were able to see the difference between a weak acid and a strong acid, whereby we said in case of weak acid, or I start with strong acid, they dissociate fully. They dissociate fully. While in weak acid, they dissociate partially. And we said if they are dissociating fully, therefore they are going to give more hydrogen ions. And in case of weak acids, which are dissociating partially, they are going to give few ions of hydrogen. So that's what we did last time, and you are able to see how they dissociate. For example, if you're having a strong acid like HCl, you dissociate it in water, then we said you will have hydrogen ions plus the chloride ions. But if you are having a weak acid, like we gave ethanoic acid, CH3, COOH, and therefore you put it in water, you will get CH3, COO, negative plus hydrogen. So we were able to see that in case of strong, they dissociate fully, and in case of weak, they dissociate partially, and we were able to see examples of weak acid and also examples of strong acids. That's what we did last time. So today, I want us to look at bases. We will also not define bases the way we defined it in Form 1, that they are substances that react with an acid to give us salt and water as the only product. We will give it a definition whereby we are saying that acids are substances that dissociate in water to form hydroxyl ion, bracket, we call them the OH ions, as the only negatively charged ions. Negatively charged ions. So we are saying these are substances that dissociate in water to give OH or hydroxyl ions as the only negatively charged ion. So we saw that acids, we are getting the hydrogen ions as the only positive, but in case of a base, we are able to identify a base because of giving us the OH ions that represent that that substance is a base. Now we are also going to categorize a base in two ways. So the first one, we are talking of strong acids, strong bases, not acids, strong bases. And B, we are talking of weak bases. Now, just from the way we had defined acids, strong acids and strong acids and weak acids, the same definition, but now the difference is that if we are talking of weak base, we will say that they dissociate, are substances that dissociate in water partially to give the hydroxyl ions. While if you talk of strong bases, they dissociate in water fully to give more the OH, the hydroxyl ions. So in case of weak bases, they are going to dissociate partially to give OH ions, but in this case, these ones are less OH ions. But when you are talking of strong bases, we are saying that they are going to dissociate in water, and they are going to dissociate fully, and therefore they are going to give more the hydroxyl ion. Now, examples of strong bases, we can have sodium hydroxide, we can have potassium hydroxide, we can also have something like calcium hydroxide. Remember the valency, therefore sodium hydroxide will have into bracket 2. Therefore, these are examples of strong bases, and we want to see how this dissociation takes place. So you are going to have, like, if you are having potassium hydroxide, you dissolve it in water, then you will have the potassium ions plus the OH ions. If you are having calcium hydroxide, to bracket 2, then you dissolve it in water, therefore you are going to have calcium ions plus 2 OH ions. Why we are having 2 is because of this we have put into bracket 2. It means that we are having 2 ions of OH. That's where we are getting the 2 OH. We are having sodium hydroxide, then sodium hydroxide will give us the sodium ions plus the OH ions. So that's how we can show that these ones are going to dissociate fully, and then they are going to give us more of OH ions. Now, when we talk about weak acids, not acids but bases, weak bases, we have said that this one dissociates partially to give fewer OH ions. For example, you can have ammonium hydroxide. Now, when we have ammonium hydroxide, we dissolve it in water, then we will have ammonium with UM, not A, plus now the OH ion. So that is an example of a weak base and how it is going to dissociate in water. So I would say that in case of the bases that we have discussed, and even the earlier on subtopic about acids, what we need to understand is first of all the definition of each one of them. And in case of bases, we have said that these ones are going to dissociate to give the OH ions as the only negative ions. And in case of acid, they dissociate to give hydrogen ions as the only positively charged ions. Then the difference is that we have weak, and the other one we have strong. So if you are talking of acid, you need to talk of the weak one dissociating fully to give more hydrogen ions. And if you are talking of strong, weak, I have said they dissociate partially to give fewer ions of hydrogen. And if you are talking of strong acid, then you will say that they will dissociate fully to give more ions of hydrogen. Then if you're talking of the base, still the same, but now you talk of giving more of OH, and the other one weak, giving few, dissociating partially to give fewer OH ions. Now, the next small subtopic I want us to look at, we are going to look at the effect of solvent on a solute. Effect of solvent in a solute. Now, when we talk of the effect of solvent on a solute, I'm sure we were able to define in Form 1 what is a solute, what is a solvent, and what is a solution. Whereby we say that a solute plus a solvent is equals to the solution. Now, we know that the solute is the solid and the solvent is the liquid. And now the solution is the homogeneous, depending on whether you are going to form a homogeneous solution or not. Now, the other thing we need to understand is when we talk of effect of a solvent on a solute, we are going to look at some solute, some solvent, two solvent. You can talk of water, and another one known as methyl benzene. We see which one dissolves in water, which one does not dissolve in water. And one term I want us to define before we discuss this part also is what we mean by a polar solvent. Polar solvent. We're interested to understand what is a polar solvent. So we would say that molecules that behave as if they are negatively charged on one end and positively charged on the other end are said to be polar solvents. They are negatively charged on one end and positively charged on the other end. Is what we are saying it's a polar solvent. For example, we can have something like water or HCl. E.g., you are having water or HCl. Now HCl, hydrogen will be positively charged and the chloride part will be negatively charged. If we are talking of water, hydrogen will be positively charged and the oxygen will be negatively charged. In fact, we normally write that one as a partial positive, and the other one partial negative, and so on. So if one is behaving that one side is positive and the other one is negative, then we are saying that that is an example of a polar solvent. Now, the next thing we want to understand is that what will happen when you are having a substance and you are having methyl benzene, whether it is a polar or non-polar solvent. Now, the two solvents I had written, I had water and I had methyl benzene. Now, water is normally polar, while methyl benzene is non-polar. This is one thing I want us to understand, that you're having two solvents, and one is polar, and that is water, while methyl benzene is non-polar. And maybe this one, it can only dissolve in organic substances. Now, we can be given a question whereby you have an experiment to investigate. An experiment done to investigate what happens when HCl when hydrochloric acid is dissolved in methyl benzene. 1 is dissolved in 1 methyl benzene, and 2 is dissolved in the water. Now, the two, one is polar, the other one is non-polar. So if you have been given that we are taking an experiment whereby we want to see what will happen when you dissolve HCl, when you have HCl and the two solvent. Now, you are supposed to explain this using that the two, one is polar, the other one is non-polar. We agreed that this one is non-polar and this one is polar. So I start with the one which is polar, that one for water. We would say that HCl is water is a polar solvent, and when it is dissolved in water, when HCl is dissolved in water, to bracket the polar solvent, it dissociates to give the following ions. To give the hydrogen ions and the chloride ions. The reason is because water is polar. Therefore, the HCl that we are having is going to dissociate in the water. Water is our solvent and it is polar, and therefore it is going to dissociate to give the hydrogen ions and the chloride ions. Now, in case the other case whereby we are having the HCl being put in methyl benzene, and methyl benzene we know that it is non-polar, therefore we will say that the HCl will remain in molecular form. The second case is that the HCl, when put or when in methyl benzene, will remain in molecular form because methyl benzene is non-polar. Non-polar, and therefore no ions will be formed. No ions formed or will be found. So the reason is because we have said HCl is the methyl benzene is non-polar. Therefore, when HCl is put in it, it doesn't dissociate. That's why we are saying there will be no ions formed. But when you are having HCl dissolved in water, water is a solvent, polar solvent, and therefore it is going to dissociate. The HCl is going to dissociate to give hydrogen ions and chloride ions. So just to summarize what we have done today, we have been able to see the definition of a base. We have said it is a substance that dissociates in water to give the OH ions as the only negative ions. And then we have seen they are divided into two. The first one, we are having weak bases. So in weak base, they are going to dissociate partially. And if it is dissociating partially, therefore, you are going to have few or fewer OH ions. Then strong. The strong base, we have said they dissociate fully, just like the acid. Therefore, have more OH ions. And we have dealt with the example. Then the last part I have dealt with, we have looked at a solvent, the effect of a solvent on a solute. We have reminded ourselves what we mean by a solute and examples. And a solute is the solid, and the solvent is the liquid. Then we have seen there are two things here. We have a solvent, a polar solvent, the one that is having partial positive and partial negative. And we have seen that in case of we have two solvents, Solvent A being water. Let me start with water. And solvent B being methyl benzene. And now you are having your HCl, dissolving them in these two. This one, we know it is polar, and this one is non-polar. So if you are having your HCl, and you want to discuss what will happen, we are saying that the HCl, first of all, when it is dissolved in water, water is polar, and therefore it is going to dissociate to give the hydrogen ions. So this one plus water, we will get the hydrogen ions and the chloride plus the chloride ions. But HCl, you react it with methyl benzene. We are saying that this one cannot dissociate because this one is non-polar. And therefore, what we are going to have, it is going to remain in molecular form. So that's what we have seen today. And next time, we are still going to look at what will happen if you are going to have, instead of HCl, you can have something else like ammonia, and we see how the two solvents will behave. So that's the end of our lesson.